As soon as it's finished, we'll start from the current slide. Now, I'll even turn on the projector today. I feel magnanimous. Okay. If you want to hear the announcements, you don't have to, but if you want to, you just go listen. You don't have to. Okay. All right. Has everyone done student course evaluations?
Yes.
Yes, good. Anyone not able to locate them? Okay. Where you go, look up, do you know how to get to your email? Okay. Look at your email, and it's an email that's talking about voting for Student Government Association. Click on that email. I know that's already over with, but it has in it the link for your student course evaluations. Okay. So there's that. Okay. I've just returned to you everything that I have finished grading. There are a few things I haven't. I'll try to get these finished as soon as I can. You can check with me tomorrow. Friday, I'm on the Birmingham campus, but I am in meetings the latter part of the morning, I think, there. And then Monday, I'll be back here. So come by Monday. I'm up here giving a test from 8 to 10, but then in my office until 2 o'clock. So come and get all the other things that I didn't get to return to you today. And those people who are going to be working on things, I'll try to get those graded too. All right, then, Monday afternoon is when our kind of final is scheduled, right? It's 2 to 4, basically. Okay? I was thinking it was Wednesday, but it is actually even number hours on Monday and odd numbers on Wednesday. So we are Monday afternoon at 2. Now, I think I said to you last time I didn't know when I was going to be out of town. I found out this morning that it's going to be Thursday, Friday of next week. So if you don't feel ready on Monday, you can come Tuesday or Wednesday. Not Thursday or Friday. I'll be gone. So you have to have the final completed by Wednesday in the business on Wednesday. Okay? So let me tell you briefly what my schedule will be next week. Monday, this is the only final I have. It's at 2 o'clock. So I'm not in class on Monday. Monday I'm free from 8 o'clock or 7:45 until 2 o'clock. So anytime Monday, come get it. I've been saying that wrong. Okay, it's Tuesday I have an 8 o'clock final. So until that really presents me a problem. I'm going to have someone come up here and proctor the last part of your exam because I've got to be on the other campus at 4 o'clock, and this final goes from 2 to 4 or 2 to 3:50, and I can't make it over there in 10 minutes because it's a mini-term 2 class over there, and we have class Monday. So I'll be here at 2, but I'll leave it at 3:15, have somebody else up here proctor the test. Okay? So, and I'll pick them up then Tuesday morning. Okay, Tuesday, I'm giving a final here in this room, 8 to 10. 8 to 9:50 actually, but 8 to 10. If you want to come take yours then, that's perfectly fine. Then I have a class Tuesday afternoon at 1:15. So from 10 to 1:15, free to come and take it. I have a class Tuesday afternoon. It's another mini-term, so it's actually a class. So don't come then. Come the latter part of that time, say after 3, 3:30, 4, something like that, I'll either be in here or down in my office. I'll be giving them their final then because I'm going to be out of town on Thursday, so I have to have the last class and final all in the same day. So that will be available to you too, but not at 1:15 because at 1:15, actually we'll probably be starting at 1 o'clock. No, 1:15, but sometime after 3 you can come, either here or in my office at 265. Then on Wednesday, all day long, 7:45 till 6 o'clock at night, I'll be in my office or around. Okay, you can come take it then. Thursday, I'm on the Birmingham campus from 7:45 until around 10 or so. That's when we leave to go to Tallahassee. Okay, and I'll be gone Thursday and Friday. But anything you need to turn in, if it's a quiz or something like that, if you don't catch me before I leave this campus at Wednesday at 6 or the other campus Thursday at 10, slide it under my door. And if it's a quiz. Test, you need to do those in minute. Those aren't take home. The quizzes are. Okay, I think that's all the announcements. If y'all want to go, you can. Okay. You're going to. Okay, good deal. What's that?
You guys have a test Monday?
Yeah, the test. The final example here is Monday unless you need to take it later.
Okay, what was the test on the previous chapter?
I'm sorry?
What was the test on the previous chapter?
The last
Okay.
I guess it's
Test
just,
Yeah, we have that?
Yeah, we can.
Oh, you're going to take that too?
can I take it later?
Yeah, well, yeah. You'll need to, yeah. Anytime, yeah, okay, I understand what you're asking.
Oh,
Anytime, those hours I just said, they all work for that one too. Okay. I'll be on Birmingham campus tomorrow if you want to take it. Well, no. Today's Wednesday. I'll be here all day tomorrow and on Birmingham campus
Yeah, I
Wednesday.
understand the same thing I got.
Okay. All right. Too many moving parts. Okay. I turned this on, I'm pretty sure, but nothing happened. All right. Sorry that took so awfully long. And I don't know why. Oh, I think I do know why. We're on example 6. Okay, slow down. Okay. We had just talked about factoring trinomials with coefficient 1. Okay? And here we go with example 6. Are there any questions before we get going on this? Okay. Now, how would you approach a trinomial like this? Okay? X squared plus 6xy minus 7y squared. Just because it has two variables, there's not much difference. I would approach the same way we did before. Unfold it. First term is x squared. What's the only possible factorization of x squared? Say again? X times x. Okay? Then where do we look next? The sign of the last term. What is it? And what does that tell you about these two signs? They're what? Different? Is that what you said? Okay, I thought that's what you said. Okay? So we'll put plus minus or minus plus. It doesn't matter. Now, we're looking for two numbers that multiply to be a negative 7, but add to be, and their sign numbers, add to be positive 6. Which is another way of saying that, two numbers that multiply to be 7, but their difference, because this is different signs, their difference is 6. Multiply to be 7, but the difference is 6. And positive 7 and negative 1, or not 7, 7y and y. You see why? It's not just 7, it's 7y squared. So you need to be able to do that. Now, before you move on, check it. And you check it by flowing. X times x is x squared. X times negative y is negative xy. 7y times x is 7xy minus xy would be 6xy minus 7y squared. Perfect. Everybody see it? Okay. I probably should have been doing that on the board rather than with my finger because people at home can't see my finger. And I don't want them seeing that I gave the class my finger. Never, I didn't say that. Okay. Now, this is the one from the slideshow. It's the example 6 in the text we haven't done and the sidebar examples we haven't done either. But let's clear this out of the way unless anyone has a question, and we will see how to proceed from there. Although this trinomial has two variables, the process for factoring still works the same. And they do this table. If this table's helpful to you, use it, okay? But if it's not the way we did it, I think it's fine. So the 7y and minus y will multiply to be negative 7y squared and add to be, with the x's in there, 6xy, okay? And so that is our answer, the same one we got, good for them. Any questions? check it, FOIL it. X times x, x squared. X times negative y is negative xy. 7 times x, 7y times x is 7xy. And 7 times negative y is negative 7y squared. Two middle terms are common, like terms, so x squared plus 6xy minus 7y squared. Perfect. Any questions? That's your answer up there. This is just your check down here. Okay, and they put a check by it. Good for them. Okay. Now, moving on to example 7, unless someone has a question on that one. And again, this is not the same as what's in the book. We'll do this one. You can do the one in the book. Oh, look at this. We don't have a leading coefficient of 1. So can we do it? How? Second? Okay. What do you always do first? We gotten lazy and hadn't said it. Second? Unfold it. Okay, before you do that, what do you always look for first? Common factors. Perfect. Does this have any common factors? 3 is certainly one. Okay, how about letters? A to the 5th is common. And then what do you have left after that? A squared. Minus 10. A. You sound a Canadian. Never mind. Okay. Minus 11. That's it. Are we through? No. We still have a trinomial here. We want to see if we can factor it. But don't forget about your 3a to the 5th. That is a factor. Okay. Now this one we're going to see if we can do it by unfolding. So what would you start with? A times A. Perfect. Where do you look next? Sign of the last term, that's negative. So that means it's a different sign. How do you want to write it? I don't care. Minus, plus. Okay, different signs. And then we want two numbers that multiply to be 11. And the difference, because they're different signs, is 10. Negative 11 and positive 1. Got it. Okay, let's check it real quickly and see. I hate this thing. I may have just destroyed the pen, which is expensive. Let's see how much still works. Ha! It came back. And it's still recording. Okay. Huh? We'll see. Okay. Ha! It looks like it does. A times A is A squared. That works. The outers are plus A. And the innards are negative 11A. When you combine those together, what do you get? Negative 10A, perfect. And then your last are negative 11. Excellent. Okay. Smiley face says you got it right. Never. Okay. Never mind. Okay. Yeah, I know. Here it comes again. This is the weirdest thing. Why? Yeah, that's the only one I got. Well, I guess the cleaning lady keeps moving it further apart. So if y'all don't mind, I'll do that. Maybe that'll keep it from catching. Okay. Any questions? Oh, that's just my doing it. Let's see how they do it. We'll clear that out of the way. And first factor out the greatest common factor of 3a to the 5th. And there they did it. 3a to the 5th times a squared minus 10a minus 11. Then see if we can factor the next part. And sure enough, they got it done the same way. And they check it. And when you multiply those two, that's the only one we did. It worked out. And then when you multiply through by the common factor, you wind up where you started. I didn't do that part, but we'll still get a big check. Okay, good deal. Any questions? Okay. That's the last example in 14.2. Homework exercises here. There's the concept check, which I'd say answer those questions. That see if you get the concepts down well. Then you can try doing 11 through 9. And then any of the problems 13 through 24. Any of the ones 25 to 42. Any of the ones 43 to 52. And any of the ones 53 to 64. Okay? I keep forgetting, what do the ones with the little block by them mean? Must mean something. Maybe that's on my math lab or something. I don't know. All right. So we finished with 14.2. Any questions on 14.2? Ooh, that's not what I wanted to do. I wanted to go back. And now I've got to find it again. (14.3). And I was thinking we had already done this, but maybe not. Didn't we do factoring by grouping? What's that? Yeah. Okay, so 14.3 is factoring trinomials by grouping when the coefficient of the second degree term is not 1. I have a feeling we're talking about something different here. Tell you what, I don't know what they're going to do here, but let me tell you how I do these. I don't call this by grouping. It's not. I know what they're trying to do, and it's perfectly fine. I'll let you read the book, but you know what we're going to do? We're going to do almost the same thing we did before. We're going to do it this way. The difference is, last time, when the coefficient for the quadratic term is 1, the only possibility is x times x, z times z, a times a. That's the only choice. Now we got several choices. 3 times 1 or 1 times 3. You were starting to do that on the last one, remember? Okay? So that means we have multiple choices. So what I like to do is what I call trial by error. No, trial and error. Okay, not trial by error. Trial and error. So, what's the only possible factorization for 3x squared? 3x times x. Okay, or we could reverse the order. We'll leave it there. Now, again, we do just like before. We look at the sign of the last term. What is that? That means these two signs have to be the same, and you look at the middle term, and that's positive, so they both have to be positive. Now we look for numbers that multiply to be 8, okay? This time they don't need to add to be 14 because you got that 3 out there. So just multiples, things that multiply to be 8. 4 and 2. We'll write them down just like you said. This is the trial. We'll see if we're going to make any errors, okay? If that's an error or not. You FOIL it, and what you get? 3x squared. Outer is plus 6x. Inner is plus 4x. Not the right number. Those add to 10x. We want a 14x. So guess what? If you don't have the right number, change numbers. So, well, now, hold on a minute. Let's first try 2 here and 4 there and see what happens. Okay? So 2 here and 4 there. And we'll also erase these and see what we get. Okay? Now, the outers give us, say again, 12x. The inners give us 2x. Look at that. Okay? That gives us our 14x, and then the last gives us plus 8. we're happy campers again, aren't we? Okay? And because you see those two middle ones add to be 14. This is what I call trial and error. I don't see why manufacture or factoring by grouping. It works. Do it if you understand that better. This is just the same procedure as before, except if you make an error, if you don't get the middle term like it is, try something else. That's why I call it trial and error. If you find it's an error, try something else, okay? Maybe it's error and trial, I don't know. Now, that's how I do it. Just to give you the flavor of what they're going to do. Any questions on this before I delete it? Okay, there's your answer, 3x plus 2 times x plus 4, okay? So let's delete that and see how they do it. Now, this is something I'm going to do later, and now I know why they call it factoring by grouping, okay? This is what I call the AC method, and this is exactly correct for this. It takes a little longer, but you're almost certain to get the answer. Trial by error, if those are big numbers with lots of factors, you can waste a lot of time and never know if you get them all. But they're going to do what I call the AC method. Here's why I call it AC. Later, we're going to refer to this as ax squared plus bx plus c. So the first thing you do is multiply a times c, AC method. 3 times 8 is 24. Okay? Now, the sum here, okay, this product is 24. What we're looking for is two numbers that multiply to be 24. That's whose product this is. We know that product is 24, but we're looking for two other numbers. Okay? And those two numbers have to have a sum of 14. So what I do on this method, and this is why it takes a little longer, is start doing all the numbers that have a product of 24. 1 times 24, that sum is 25. That won't work, right? 2 and 12, that sum is 14. We got it on the second try. Okay? So this is pretty fast on this one. Okay? So what do? We go and, now my pen is doing weirdly. We do, quit this. Okay. We do 3x squared. I'm sorry, it's putting all those extra lines in there. And then we do make this a plus 2x and a plus 12x. Okay? You see from there, I'm sorry, I can't make it quit. Okay? Plus 8. Okay? So once you've written it like that without all the squiggles in it, then you can group. It's getting worse. And it's not that funny. Okay. Now, what can you do in that first group? You look for common factors. What common factor do you see? Say again? X. What do you have left? 3x plus 2. Second group. Plus 4. What do you have left? 3x plus 2. I almost feel like I'm writing in calligraphy or something. Okay. Now what do you have? Common factor of 3x plus 2. And what you have left is x plus 4, which is the same answer we got before. Okay? So pay your money and take your choice. You've already paid your money, so take your choice and see which one you prefer. For simple ones, I like trial and error. For more complex ones, AC method, or what they call factor trinomial by grouping, which to me makes no sense because you can't factor by grouping unless it's got 4 terms, but a trinomial only has 3 terms. But you're manufacturing a 4th term by splitting that cross term into 2 other terms. And that's what you get by your factorization. Okay? And this is a lot like they did with their box when they didn't have to. It's going the same procedure. Okay? So there's their factoring by grouping. Can I leave that on, or, can I erase that and go on to the next, or do y'all need it a little longer? Okay. Example 1, there's one in the text that's not like this one, and they show you again how to do it, and then they got one in the sidebar, which you can do as well. Okay, let's see how they finish theirs. I'm going to erase all this chicken scratch. Okay, and here's what they did. Let me back up. Okay, yeah, it's the next thing. So what they're going to do, just like we did, except they're starting off by putting two terms in here. And the two numbers that go here, we want to multiply to be 24 and add to be 14. Okay? And they started with 1 and 24, 2 and 12. As soon as you got 2 and 12, stop. There's no reason to do any more. Okay? Stop. 2 and 12 will do it. You don't need to go any further. But they went on and did the rest of them too. But 2 and 12 will give you your plus 14. That's what you put in there. 2 and 12. Put them in there. 2 and 12. And factor by grouping. Common factor of x times 3x plus 2. And the second group, common factor of 4 times 3x plus 2. Now you've got a common factor of 3x plus 2. What you have left is x plus 4. Isn't this thing song obnoxious? Yes. Okay. And there's your x plus 4. And there's your x plus 4. Okay. Wasn't it? Okay. All right. Just seeing if you're listening. Okay. So, make sense? Oh, you needed the third test too, right? Okay. All right. I'll take that and put it right there. And you got other papers on your desk. Test 3. That's the only one you needed, isn't it? Did you do the one with the graphing? Are those both quizzes or is one a test?
Both quizzes.
Okay, so you need the quiz that went with the test, with the graphing too, didn't you?
Yeah, I didn't do this one.
Huh?
Yeah, I need this.
You need that one, okay. So let me go back and find that. You'll need one page of this is front and back, and you'll need, this is a terrible rendition of the graph. It's very faint, but you'll need a bigger graph for one of these problems. And then here's test 2. Okay. And then when you finish that, come and get test 3.
I can get anything finished if time went by so quickly.
What's that?
I can get anything finished, so I have to come back and do it later.
Say that one more time.
I couldn't get anything done because time went by so quickly.
Okay.
Can I do this later? One other question.
Okay.
Got a screen, right?
What's that?
Physics, right? You got an object right here, right? And it's about spinning.
Now what's this again?
This is for another project.
Right.
I'm trying to ask you a question. This is moving about 500, 2,000 RPM.
Okay.
Do you know how to calculate the fluid physics between the surface area?
Okay. Are you talking about for lift purposes?
Yes.
Okay. It's Bernoulli's principle is what you're dealing with there. Okay. And how you calculate it, you would have to know the length of the path, and so that arc length. So
it's 14 centimeters across.
Second.
It's 14 centimeters in diameter.
What is?
This. It's
Yeah,
rotating.
that's not a circle. Oh, that is a circle.
Yes.
Oh, okay. I thought that was an oblong. Okay, you're doing a
Yeah,
three-dimensional.
it's just
Okay,
general.
right.
Yeah.
Okay, and then I don't understand. What's it doing? That's being revolved around
No,
something?
it's hovering.
It's what?
It's hovering.
Hovering. I have to have another dimension to know very much. If that's just a circle, a hovering circle isn't going to give you any lift.
Okay.
See, I thought that was a
rotating
blade.
fast,
Huh?
It's rotating fast enough where the other forces aren't, like gravity. Like,
Yeah.
you know, you have gravity, right?
Right.
Right. And this is because it's using that.
So you have to have something to give you lift.
Okay. Well, I mean, like
If
it's got
it's gonna
fins.
hover.
It's got fins in the inside, so that's generating the upward force.
Okay.
Right. So I mean, like this and this is equal.
Right.
Right.
Yeah, that would be what's required for hovering. Okay, so I'd have to know something about the,
Okay, and it's rotating, right?
right.
In RPM of 500 to 2,000.
Okay, get one more, okay. Okay, but I still need some sort of another piece of information to know how to get the lift. I don't,
Okay, it's literally about the shape of it.
yeah, that's basically what I
You
need.
need the shape, like the exact shape. I can draw the exact shape. I just drew a general shape.
Okay, well, I thought that was just a circle.
No, it's not a circle, it's a disc.
A disc,
Yes.
okay.
Here,
All right.
here, I'll draw it.
I've got to, okay, we got to continue with class, sorry. I
Okay.
thought it was going to be something
So, yeah,
pretty
okay, I
easy.
thought you were going to zoom, yeah.
That would take a bit of calculation, I think.
Okay.
Sorry.
I'll go see about aeronautical engineering.
Okay.
Appreciate this. Good, thanks.
All righty. And when are you going to come and finish this?
Next week.
Okay. All these people are bringing me gifts. Is that a quiz or a test?
This is a test.
Okay, tests are not take home.
No, I know, I said, can I come tomorrow?
Yeah, but you'll need to turn it in and pick it up.
Yeah.
Yeah. Okay. What's that? Yeah, you did. And this is finished?
I didn't finish, I wanna come back and.
Oh, you
try.
want to finish, come back,
Yes.
okay, because we only got two missing, okay. All right. All right, we just finished doing example one sometime in the past, and we're running rapidly out of time, yes.
Class, the class started next door.
Oh, they did, okay. I've got to leave in short time anyway, so, if you're working on a quiz, you can take those home with you. If they're working on tests, you need to turn them in and come back tomorrow sometime and finish it.
What time can I come?
Okay, tomorrow,
Yeah.
my office hours are from 10:45 until 1:15.
Okay.
You got the quiz? Okay. 10:45 to 1:15. Okay. You got it too? Okay. 10:45. Okay. All right. I would never have thought of calling this factoring trinomials by grouping. I call it the AC method. Both they're identical, so you can call it anything you want to. You can call it Fred, whatever you want to call it. Okay. So I can't get it to advance. Oh, there's the answer. It's done that again. Okay. And you check it by foiling it, and sure enough, you get what you started with. All right. Now let's try another one. They call it by grouping. We'll try both methods. You do whichever you like best. Okay? Or you tell me, you want to do AC method, which is grouping, or you want to do trial and error. I don't care. Fred, okay? Which one's that? Huh? AC, okay? We'll do the AC method. Here's A, there's C, okay? Your B is 3, okay? So what is A times C? Is negative 10. All right. Now the B is need to be the sum of the two factors here. Well, since that's a negative 10, you know one factor is going to be positive and one's negative. Since the B is 3, which one's going to win? Who's going to be the bigger number? The positive. Okay. So then let's only list with negative small numbers and positive big numbers. So what are the possible factorizations for that would give you negative 10? Negative 1 and positive 10, that's not going to be 3. That's going to be 9. So that one's out. Okay, next. Negative 2 and positive 5. Oh, you always want the bigger to be positive. You just told me that. And what do those add to? 3. Ding, ding, ding. We got it. Okay? So what do we do with it? We take this 10n squared, leaves that exactly alone, and split this plus 3n into a minus 2n plus 5n. That's how we're making it 4 terms. And then you got your minus 1. That's the same as what you had before, multiply and see. I mean, combine like terms to see. Yeah, this is the same as that. Except for the stuff on top. Okay? Now, what do we do at this point? Well, group. That probably means the same as combine. Okay? And what do you notice about the first group? Second, common factor of 2n. And what do you have left? 5n minus 1. And then just for funsies, we're going to put that coefficient in there, 1 times 5n minus 1. Okay? Now we have common factor of 5n minus 1. And what do you have left? 2n plus 1. And now we check it to see if that's what we got. 5n times 2n is 10n squared. Perfect. 5n times 1 is 5n. Minus 2n is 3n. Perfect. And then minus 1 times 1 is minus 1. Yes, we checked it, and we got a smiley face to show it. Okay, makes sense? Yay or nay? Okay, yay! Okay. We will then see how they did it. Hopefully they did it similarly, but if they did it a little bit differently, you know what? It's going to be okay. Anyone need that a little longer? What's that? Yeah, this is recording, right?
What page is it I'm talking about?
Right now we're something similar to the bottom of page 937. Okay, 14.3. Okay. All right, to erase, and you can see. Oh no, y'all still writing. 937. The book calls it factoring by grouping, which ultimately you do, but when they say factor trinomials by grouping, you say, no, you have to have an even number. Yes?
What number is that? First answer underneath the 4.
Okay. Right here? Is this one? Wait, what? Right up here? Second?
The first number 4. Yeah,
That's a 5. 5n minus 1, that's from here. And then 2n plus 1 is from there. Okay. Got it? Okay. I'm going to erase this, and then you can watch them do it. Let's see if they did it the same way. Well, the product is negative 10. That's what y'all found. The sum is positive 3. We saw that too. And we set up a table over here. And I think this is ridiculous. Okay. There's no reason to put the big numbers here because the sum is positive, you know that the factors here, the small one's going to be negative, the large one positive to make this positive. So don't even write that down or that down. 1 and negative 10, that has to be negative 9. Ooh. Yeah, that has to be, I said it backwards. If you don't do this one, you don't do that one. Negative 1 plus 10 is positive 9, that's positive 3. No, that won't work. Negative 2 plus 5, sure enough, that's 3. So this is the one you use. And watch them use it. There, they chose that one, okay? And so now, those are the numbers, negative 2 and positive 5, they put in there. There, they did it. They crowded it in, sort of, but they did it. And then they factored by grouping, and the first group has a common factor of 5n, leaving us a 2n plus 1. The second group, oh, notice here, they grouped it different than we did. I put the minus 2 with this. Is this going to give us a different answer? No, because you do a minus 1 times, now this time, and this is while I like our way a little better, though I backed into it, if you factor out the minus, you have to change both signs here. That becomes a positive 2 and positive 1. Now you get common factor here, and watch them color that in. There they are, and then you pull that out, and what do you have left? 5n minus 1, and there we have it completely factored. Check it, and sure enough, you get the right answer. Make sense? Now you could also do that in trial and error. We don't have time to go back and do that. Okay? Now, that was 2A. We're out of time. I've got another class. Sorry we didn't get any further, but what I would suggest for you is go on and look at 14.4, which is basically what I've been doing all along, factoring trinomials by the FOIL method, okay? Only I call it unfoiling. So that's nothing new. So go and review those. And then special factoring techniques. Basically, these are taking the special products we did in the last chapter and now factoring them. If you have a difference of two perfect squares, they factor into the conjugates of each other, of the square roots. Okay? So you can go back and look at that. I would do so because I don't know what's on the final. I've not given one of these finals in this in a long, long time. I don't make up the final. But that's the last section in this chapter. So that's as far as we're going. Oh, no, there is one more. 14.6. I don't think that's was in the course description. So, okay. 14.3 ended with the exercises on 939 and 940. Factoring by the FOIL method, which as I've been showing you all along, is 14.4. That's from 941 through 946. And the special factoring techniques, 14.5, are from 947 through 952. Okay. I think y'all will be in good shape for the final. Come and see me and pick up your remaining tests. I'll try to get them graded, but I've had so many things turned in the last few days, I'm way behind in grading. So I'm going to do my best to catch up as much as possible. Good deal. What's that again? On campus? I'll be here from 7:45 until 6 o'clock. No, wait, until 4, until this time right here, because I've got to go to the Birmingham campus for a class at 4. So.
Can Monday morning I take my test 3?
Yeah. Okay. Yeah.
We just come in on Monday at 2 o'clock to take our finals.
Yeah. That's when you come take the final. So you can come in any time earlier. See, I thought I said earlier I had a final at 8. I don't. That's on Tuesday. So anytime from 7:45 in the morning until class time, 2 o'clock. I'll be here. Probably down at 265.
When do we take the final again?
2 o'clock on Monday.
2 o'clock on Monday. Same class or different?
Yeah, right here.
Okay.
But you'll have 2 hours to do it, not an hour and 15 minutes. But I won't be here for the full 2 hours. I'll get someone else to come in. Uh-oh.
Yeah. Someone left their test that you graded over.
What's that?
Someone left their test.
Okay. Let me...
That you graded. It says Nadia.
Oh, sure. No, Nadia just left.
Yeah.
How did Gis get over there? She said right there.
I'm
Oh.
gonna go ahead and turn in Dr. Fowler what I turned in on my test because I do have to work tomorrow. I just thought about it.
Right.
I have to work tomorrow morning. Well, actually, I go in from 7 p.